Hello, mathematicians. Today we're going to look at separating separable differential equations. But before we do that, let's do an example of a problem we've done before. Given dy dx equals sine x and the point 0, 2 on the solution curve, solve for the particular solution to the differential equation. So if we want the particular solution and we have a differential equation, we're going to need to get back to the original equation by taking the integral. So if I have dy dx equals sine x, I need to integrate both sides. So I get y equals negative cosine x plus c. To find the particular solution, now I need to plug in my point. So I get 2 equals negative cosine 0 plus c. Remember, 0 is over here, so cosine of 0 is positive 1. So we get 2 equals negative 1 plus c. Add 1 to both sides, and you get 3 equals c. Remember to rewrite the equation now and replace c with 3. Now, let's go back to this first step. In order to integrate this, I need a dx on this side. How does this dx get here? Well, what really happened was I multiplied dx on both sides, so that canceled, and we had our dx here. And the integral of dy just gave me y. So what we were doing was separating our variables. Now, it didn't make much of a difference here because we only have one variable. However, if we have an example like this, our x's and y's are together. So in order to find the solution, we need to separate our x and y's. To do that, first, you multiply both sides by the differential in the denominator. In this case, we have dx, you might have dt. So you multiply by dx on both sides, and you get dy dx equals some function with x and function with y dx. Now you need to get the x's on one side and the y's on the other side. If there's a constant, it can stay on either side. However, usually if we're trying to solve, we want to solve for y, so it's easier to keep it on the x side. But keep it on the side that's easier. So let's do an example. We have dy dx equals 3x squared y. First, multiply by dx. These cancel. Dy equals 3x squared y dx. Now I still have a y hanging out with my x's. So we need to divide by y to move it. So we get 1 over y. Remember, dividing y is the same as 1 over y. Dy equals 3x squared. These cancel. Dx. Now that we have all our y's on one side and all our x's on the other side, we would be able to integrate to find our solution. But in this video, we're just going to focus on separating them. Let's do another example. Dy dx equals 3x squared plus y. So we want to separate our variables. Times dx on both sides. Now, because we have plus, we need to put parentheses. So we get dy equals parentheses 3x squared plus y dx. Now, how can we get our y to the other side? We can't subtract y because it's being multiplied by this dx. If we distribute the dx, then they'll still be attached. It turns out that there's no way to separate these variables. This is not separable. So we're not able to solve this. In fact, the best method we have is to use our slope fields to get an approximate solution, because we cannot find an exact solution for this differential equation because it's not separable. That's why we did slope fields first, because they can be used for any differential equation. Let's do another example. We have dy dx equals x divided y plus 4 divided y. So multiply dx, we get dy equals x plus y, parentheses, plus 4 over y dx. Now you might be tempted to say, I have plus here, I can't just get rid of my y. But notice both these terms have y, so we can factor it out. dy equals 1 over y, x plus 4 dx. So now we can get rid of this term by multiplying by y over 1, the reciprocal, or just y, on both sides. So we get y dy equals, these cancel, x plus 4 dx. Now our x's and y's are separated, we can integrate to find our solution. Let's do one more example. Here I have dy dx equals e to the x plus 2y. So what's my first step? Times dx on both sides. So I get dy equals e to the x plus 2y dx. Now what can we do? We want to get this y to be on the other side. Well, remember our properties of exponents. If we have 2 to the 3 plus 1, well, that's 2 to the 4, which means 2 times 2 times 2 for those 3, times 2 for that 1. Well, that's the same thing as 2 to the 3 times 2 to the 1. So we can rewrite this expression using this property. So we get dy equals e to the x times e to the 2y dx. Now we can move this y term to the other side by dividing. Divide e to the 2y, divide e to the 2y. Now, remember, if we have an exponent in the bottom, we can bring it to the top by making the exponent negative. E to the negative 2y dy equals e to the x, this cancels, dx. Now we have our y's on one side and our x's on the other side. I hope through these examples you've learned how to separate differential equations, so we have only one variable on each side.